Okay, we shall start on basic part 2. So for this part, the main focus is on complex sketch. Relatively complex. So this shape is can actually be done. This model can actually be done in one single step, which is create a sketch using these constraints and dimensions, then extrude it across directly. This can be done within one step. Yeah. The main focus will be how to create this relatively complex sketch. So same as previously, we create a new file first, then we save it as basic part 2. Then we can create a sketch on the front plane. So same as previously, we use lines and curves to roughly sketch out this shape. Do know that this arc over here this arc over here is tangential is tangential to this horizontal line. So to create this arc, there's two possible ways. First is while dragging a line after finishing this line, instead of continuing the straight line, you can move your mouse cursor back to this point and then drag it out again. Yeah, this will create a tangential arc. You can see that you can see it from this blue square over here, which indicates a tangential relationship. Yeah, and of course, another way is to just create a normal arc. Just to create a normal arc, then make these 2 points coincide or merge these 2 points, and subsequently make this arc and this straight line tangent to each other. Yeah, both methods will work. Yeah, it depends on the actual situation. Because the first method will automatically add this tangent constraint. Sometimes if we don't want the arc to be tangent, then we have to manually delete this. So under such circumstances, the second method, which is to create an arc uh, directly, then add those relationships subsequently, might be a better choice. Yeah, but all these depends on the actual situation. Yeah. So okay, then we need to define these variables. Yeah, since we over here we can also use these variables in our dimensioning. So 563865. Yep. So next we know that this dimension is C and this vertical height is B. So smart dimension, this is C and this is B. Then we can add the remaining dimensions one by one. These two angles are 30 degrees. One way to add them is create a construction line using the centerline function, extend it outwards. Yeah, extend it outwards, create this horizontal construction line, then define then define the angle between this line and this line as 30 degrees. This is the first method. But in this situation, it's actually not necessary to define this construction line. we can since this construction line is simply an extension from this solid line, so we can actually directly use this horizontal solid line as the reference line. So same as just now, we select this slanted line, then click, then under smart dimension, we click on the horizontal solid line. Then we can see that it defines this angle. Yeah, we can move our mouse cursor around, and you can see that other relevant angles can also be defined. In this case, this so-called extended construction line are automatically created. Yeah, in this case. Yeah, you can see that, you can see from here. This line automatically extends to fit this this acute angle definition. So we define this as 30. Yeah. Both method works. Yeah. Then we can define the remaining dimensions. This is 1, 5, 15. This is also 1, 5. The last step will be this arc over here. It has a radius of 50, R50, R50. So we put this as 50. For this hole, you can extrude the sketch first, then after that use extrude cut to dig this hole. But it's also possible to draw this in this sketch so that this part will not get extruded. So let's draw this hole or this circle. It has a radius of 15. Sorry, it has a diameter of 15. This phi sign over here indicates a diameter. Then is the center point of this circle is 19 mm away from the bottom, as well as 31 mm away from this point. So defining the distance, we can use we need to use the center point of this circle as a reference. So you can click on the center point directly, then followed by the second point of interest, and define the dimension. It is also possible to just click on the circumference, the circumference of the circle, and click on the line of interest. Yeah, both will give identical results. Yeah, although you click on the circumference, SolidWorks will still automatically select the center of the circle for you. So this is 19. I believe that's it. You can see that this sketch is fully defined. The bracket minus sign in front of the name does not exist for now. So let's extrude it across. Yeah, you can be blind or you can be plain. Usually I prefer be plain, but in this case, use blind is also fine. We need to extrude it for 56 mm, which is the value for A in this case. So equal global variable A. Okay, okay. Okay, I think I accidentally closed this. Yeah, I accidentally closed the feature tree. So if you click on this button over here, the feature tree will collapse. Yeah, you can show it by just clicking at this button again. Yeah. So okay, I'll repeat what I did just now. Go to extrude, then set it as global variable A, then press OK. And we can see that this is the volume. The reason why we want to define dimensions using variables is we can change this variable easily. For example, we know that this height is B and this length is C and the extruded distance is A. For example, we want to change some dimensions. We want this block to be higher, which means, in other words, we have a bigger B value. Yeah. So we want this higher. We want this block to be higher and thinner. So we can increase our B value and decrease our A value. So for example, we can directly go to the equation tab. Yeah. And over here at the value slash equation column, we can directly increase the B value. Let's say we put it as 50, and we decrease the A value. Let's say we put it as 32. Yeah. All these are just examples. Yeah. So after that, click OK. Now you can see that the model has been automatically updated. It has become like taller and thinner. So okay, let's change back to the original value. 5638. After changing value, you can click Enter button to confirm your confirm the value you key in, and press OK. This is a relatively fast way to design multiple iterations with similar shape but different dimensions. Yeah, in more advanced topics, for example, like SolidWorks Professional CSWP, they will ask you to CAD a lot of similar models within a very relatively short period of time. So under such circumstances, using equations can be quite useful. Okay, I believe that's all for this video.